Hey everyone, so today's video is gonna be about esterification, which is one of the key reactions in organic chemistry, right? So we're gonna deal with esterification reactions right now. Imagine we have a carboxylic acid, which is a 2-carbon acid, so it's obviously ethanoic acid, and we have a 3-carbon alcohol, we call that propanol, right? Now what happens if these are combined in the presence of concentrated sulfuric acid? The OH from the acidic side and the H from the alcohol combined together. So the OH from the acid and the H from the alcohol give us a water molecule. What happens to the acidic side and the 3-carbon alcoholic side? They are combined together through a new bond between the carbon and oxygen, and that is what we call the Ester linkage. Carboxylic side on the left side, because you can see this 2-carbon side came from the carboxylic acid. It has even that carbon double bonded oxygen. On the right side you can notice the alcoholic side, which must have come from the 3-carbon alcohol. In the middle, we have the Ester linkage. Now imagine a 2-carbon alcohol, which is ethanol, and a 4-carbon carboxylic acid, which is butanoic acid. If they are combined together, the H side from the alcohol and the OH side from the acid combine together to give water molecule. The 2-carbon alcoholic side and the 4-carbon carboxylic side are combined together and they make a new bond between the carbon and oxygen. On the left side we can see a 2-carbon alcoholic side, and on the right side we can see a 4-carbon carboxylic acid side. In the middle we have an Ester linkage, which is COO. Let's try to learn how the formula of ester works with equations. So we'll see how we open up structures. Imagine we have CH3COOH, and we have another formula which is HOCH3. Now you would know that COOH means the carboxylic acid functional group. So I'm going to open the structure. On the left you see CH3, which means a carbon with 3 hydrogens. We have opened the structure of the acid. Let's open the structure of the alcohol now. We see OH means the hydroxyl group and CH3 means 1 carbon with 3 hydrogens. We know that the alcohol always loses the hydrogen atom and the carboxylic acid loses the OH. What happens is that we get an ester. So let's draw it from the left side. We draw a CH3. Then what we draw is a carbon with a double bonded oxygen, and then we jump on drawing the remaining part of the alcohol. So you see there's 1 oxygen and there's a carbon with 3 hydrogens, so I draw it. You can identify the Ester linkage right in the middle. Let's write the formula. The CH3 can be shortened into simple CH3. There's a carbon double bonded oxygen, so I write CO. There's another oxygen atom which is again oxygen, and there's another CH3 on the right side. So this is my whole ester. You can see in the middle there's a carbon double bonded oxygen and 1 more oxygen. That is the Ester linkage. Now we know that the esters are formed by the acid and alcohol, and we get a water molecule. Let's try one more. Imagine we have C3H7COOH, and we have obviously an alcohol which is HO, let's say C2H5. Let's open up the structure. So the carboxylic acid part can be opened up into the C3H7. So 3 carbons and 7 hydrogens. I'm drawing all the hydrogens over here. This comes on the top, these come at the bottom, and there's 1 more hydrogen. The COOH part means a carbon double bonded oxygen and OH. The alcohol structure can be opened up as well. So there's a C2H5, which means 2 carbon and 5 hydrogens in a simple chain. The OH part is the hydroxyl functional group, so I write OH. When I combine them, the alcohol loses the hydrogen atom, while the acid loses the OH. They are combined together. So starting from the left side, I can see there is 3 carbons and 7 hydrogens starting from the left side. And then there is a carbon with a double bonded oxygen on the carbon of the carboxylic acid group. Starting from the alcoholic side, now jumping onto that, I can see 1 oxygen and 2 carbons, which reminds us that this is the alcoholic side. Now you can see the structure is pretty simple. Starting from the left, you can notice 3 carbons and 7 hydrogens. On the left side, there's 3 carbons and 7 hydrogens. So it's C3H7. Then you can notice there's a carbon double bonded oxygen. So I write a CO. There's another oxygen, so 1 more oxygen, and then there's C2H5. So I'm shortening it, I'm making it more condensed. This is my ester. You can notice ester linkage is right in the middle, which is COO. A carbon double bonded oxygen, then 1 more oxygen. What is the byproduct? Byproduct is water. Acidic side comes on the left because the carbon double bonded oxygen was on the left and alcoholic side was the right side. Obviously, water is the byproduct. Let's try some practice of drawing ester structures. So drawing ester structures. Let's try it. Let's see. Imagine we want to draw methyl propanoate. So methyl means 1 carbon alcoholic side, because first part of the name is alcohol and the second part is always acid. So propanoate means 3 carbon acidic side. The O8 always indicates the acidic side of the ester. So my suggestion is first draw the ester structure. Draw a carbon with a double bonded oxygen, then 1 more oxygen. The left side here is the carboxylic acid side and right side is alcohol. So draw 1 more carbon for the alcoholic side because it was a methyl, which means methanol was used. The acidic side gets 3 carbons in total. So I am drawing 2 more along with the hydrogens. The left side is the carboxylic side, center is the ester. So carboxylic side on the left and right side has the alcoholic side. We can see the ester is in the middle, right? Now butyl ethanoate means that 4 carbon alcohol, because alcohol comes first in the naming, and then ethanoate means a 2 carbon acidic side. Again guys, draw the structure of the ester linkage first. A carbon with a double bonded oxygen, then 1 more oxygen. The left side is the carboxylic acid side, right side is alcohol. Draw 4 carbons for the alcoholic side along with the hydrogens, and on the carbon double bonded oxygen side, draw 1 more carbon to get a total of 2 carbons for the ethanoic side. You can see ester linkage in the center, you can see carboxylic side on the left, you can see alcoholic side on the right. Guys, this is how we draw esters. In the coming videos, we'll learn more about writing their names and their structures. So I hope it's everything clear to you guys. Stay tuned guys.